I want to talk about ephemeral containers, and I want to talk about a specific use case for them because I kind of came with a problem that I wanted Kubernetes to solve for me. So yeah, let's start a little bit. As I was already presented to you, I'm a team lead in the engineering department at Kubernetes. I have more of a sysadmin background, and for some reason I started writing more and more software, and I guess never stopped with that. So it is what it is. Now, these days, I'm doing software engineering, and I've been working with Go and Kubernetes since 2018. If you want to find me, usually my handle is mbig on most major platforms. So yeah, let's get started with what we actually want to talk about. I have an agenda for today. First of all, I want to talk about my use case. And that use case is debugging a Go application that ideally is already running in Kubernetes, because some problems you might not be able to figure out on your local machine, on your local system, but you really want to see it in all the moving parts. To do that, we need something that is remote debugging. I'll talk a bit about that. And after that, we will talk about ephemeral containers, because I found ephemeral containers to be my solution to the use case, to the problem that I have. We're going to talk about Delve. We're going to talk about launching Delve as an ephemeral container, how you can even do remote debugging in your favorite IDE, and then we're going to do a quick live demo. So let's hope that works. Before we jump into my use case, who here has heard of ephemeral containers before, like seeing this talk on the agenda? Okay, that's quite a lot of people. That's good. That's good. Who has used it? Who has used ephemeral containers in the past? Okay, that's more people than I thought. So I hope I can still teach you something new. Or if you're gonna correct me in the Q&A, let's see. First of all, let's start with what I want to do. What I want to do is I want to debug an application. In my specific case, and probably in a lot of your cases as well, it's a Go application. But, well, the principles that I'm applying here should work with most debuggers for different languages, as long as they speak a couple of protocols, they fulfill a couple of criteria, we're going to talk about them. But in this case, we're going to talk about Go specifically. So because we're talking about Go specifically, we are also talking about Delve, because, well, Delve is, I would say, the de facto standard Go debugger. Let's do another physical workout after the lunch with raising your hands. Who has worked with Delve before to debug an application? Okay, that's a few people less, and I'm not sure if the overlap between the people with ephemeral containers and with Delve, if that was too big. So yeah, maybe we'll figure out how these concepts can work together. So yeah, Delve, as said, is a debugger. It kind of does what you expect a debugger to do. And I think we have Go experts in the audience who know more about using Delve than I do. Let's be honest about that. But kind of one of the features that you would expect in debugging to work is setting breakpoints. You set a breakpoint, your application halts, and it waits for you to do something. So you can read local variables, you can sometimes, and with Delve, you can maybe even manipulate variables, their content, to try out what would happen if. But in general, you want to observe an application state in a specific situation. And that is what you can use Delve for. You can use it locally, and we're going to talk about how you can also use it remotely, but more in a bit. Because the first question that we need to ask ourselves, are we capable of debugging? And the reason behind that is most of you are probably more or less, you have permissions on your systems that will allow you to do most of these things. If you are, for example, on macOS, things work a bit differently there. But if you are on a Linux system, well, if you're root, you can do most things anyway. But we are going to talk about running the debugger in Kubernetes later. So we want to be sure that we only give the permissions that we want to give, that we need to give, and not more than that. And the thing that we need to do here is we need to set a specific Linux capability, and that is cap sys ptrace. There's a couple of things going on. This is from the man page for Linux capabilities. Has anyone not heard of capabilities before? Okay, so the capabilities in Linux are kind of a more specific permission system. So traditionally you had, okay, your root or your normal user, but for some processes you don't really want to run that as like full-scale privileges, being able to interact with the Linux kernel to the full degree. So you give it permissions to do specific things with the Linux kernel, and that is capabilities. And in this specific case, we are mostly interested in being able to use ptrace. And, well, that's what the capability includes. There's a couple of more stuff on here that you can see, but mostly, really, it is this ptrace functionality in the kernel that we are interested in. And why are we interested in that? Because we want to follow what another process is doing. As you can imagine, usually that is not a permission that you want to give a process, because if you do, well, they will be able to read the process memory, so you can extract secret data, you can, well, basically access everything that that process has access to, and that's kind of bad if you don't explicitly want to do that. So this is the question. This is the capability that we'll need. We'll go back to that later, but this is one of the requirements that we have, and we're going to use that in a bit. Now there's also something else. If you want to debug an already compiled Go application or Go binary, you can do that with Delph. That's possible. You can attach to a Go binary. The problem with that is you might want to set these flags here. So this is kind of a way to produce a debug build where you essentially know what you see is what you get. Because usually the compiler thinks it knows better than us, and it will optimize away some of your code to make sure that the resulting binary is as efficient as the compiler thinks it can be. But because Go debugging works mostly by passing, okay, I want to look at a specific breakpoint on a specific line in the source files, because the compiler might mess with your code before building the binary, that line is actually not that line anymore in the final build. So if you have troubles with this, you might not need this, but if you debug and something feels odd, you might want to have a specific debug build that sets these flags. One is disable optimizations, and the other one is disable inlining. So yeah, the compiler compiles your code as you give it to it, but that usually means it's less efficient, because usually the compiler knows better than we do. So yeah, that's essentially what you might want to keep in mind. And now let's talk about something, because so far we've been talking about attaching to a process running on the same system. So that means, okay, I have my Go application running, I log into the Linux server that is hosting that, and then I can debug from there. But we can do a bit better. We can do remote debugging, because you might want to do this from your local machine, because your tools are properly configured or whatever. And for that, and this is something that mostly comes out of Visual Studio Code, but is something that you can apply without VS Code, the debug adapter protocol. I'm not sure if you should call it DAP or DAP. I'm going to call it DAP, but I don't know, 3-letter words. No one has an idea how to pronounce stuff. So DAP works with the following concept. You have a bunch of debuggers. In our example, it's Delph, but if you work with other languages, you might be using a different debugger, for example, a debugger for Node.js, or maybe you're debugging a C application. And maybe they implement like remote debugging, but maybe they have their own protocols. Delve actually has its own protocol for remote debugging, but we're not that interested in it because it's a Delve-specific protocol. The idea behind DIP is that you have an adapter between your IDE or your like tooling of choice that is supposed to debug your application and the actual debugger. Some debuggers have implemented the debug adapter within their own code. So we'll take a look at that. Delve actually has their own implementation of this, but the original idea of the people behind DIP was, we don't really expect every debugger to implement our protocol, so we will build debug adapters. And these debug adapters speak a common language, a common protocol, to actually debug your application. So, for example, setting a breakpoint, that's a standard protocol call in DIP, interacting with the code. And we're going to use this in a bit. Because we have these capabilities in Delve itself, that means we can have our application process. I'm just gonna, let's see if this still works. It does, okay, nice. The application process, which is like our compiled Go binary. We have the Delve attach, which is a separate process, but which used ptrace to access or to attach to our Go application. And then, and this is kind of where the magic of remote debugging happens, DAP is a network-capable protocol. That means I can go across network boundaries to connect to the debugger that is actually running against my Go application. And that means I'm no longer bound to the same machine. That means I can do a network call from a client. In this case, it's Delve Connect. So Delve has its own client for DAP. Actually, I think it's speaking its own protocol, but point being here is you can connect over the network, and then you can cross network boundaries to run debugging. And there's a little command here. I always like sprinkle in a bit of like the actual code calls that you can, or the actual command line calls that you can do. And in this case, it's like Delve attach. And then here, you open a network port. So if you just do this locally, you could also do a Unix socket. They would still speak a network protocol over that, but you would be sure that your network, like it's not actually connected to a port on your machine. But in this specific case, we actually want to cross network boundaries. So we're going to take a look at that. OK, now I have defined my use case. And now I want to talk about, OK, how can Kubernetes help me with that? Because, as I said earlier, I kind of want to run my application where it actually has its problems. If I execute it locally, maybe I will run into the same problems, maybe I will not, like who really knows? Is it a thing that only happens under load? Can I simulate load? Is it maybe the environment that, or like the configuration within the container that is weird? So I want to do this in Kubernetes. And all of this would be possible without ephemeral containers, but you would need to bake the whole like debugging session into your containers, or you would need to start like a secondary container in your deployment. That would also mean that you need to restart your pod. And that could mean that your problem is maybe going away. Maybe restart fixed it. Yeah, that's the quick solution, and it might work for a few minutes, a few hours, a few days, but you didn't really figure out what was going on. So you don't want to restart your pod. You don't want to restart it with a new configuration. You don't want to add a container that runs kind of as a sidecar because, yeah, maybe the problem is still there. Maybe it's not. Maybe that changed enough already for your solution or for your problem to be gone. Who really knows? No idea. And this is the situation that you had in Kubernetes up to a specific point. So you had two types of containers you could add within a pod, within like the smallest schedulable unit in Kubernetes. One was the init container, which ran before the actual container. So that is also something that I believe recently changed with the sidecar pattern, but I'm actually not sure about that. But for the longest time, using an init container for this was not feasible, because the init container runs before the actual containers. So putting your debugger in a place where it like would wait for the application to start, I don't know, doesn't make much sense. Now, with Kubernetes 1.25, a third kind of container was added to the pod specification, and that is the ephemeral container. And that means that I can now not only create a pod with init containers and containers, I can actually add ephemeral containers to pods at runtime. This is one of the few fields in a pod spec that is not you can change it. I'm missing the word. But essentially, this is one of the few fields you can change for a pod while it's running. Some changes in Kubernetes recently also allowed you to change resources, to like change the resource usage of or the allowed resource usage of a container, like in real time. But most fields you can actually not change. And the ephemeral container field is different. You can do this while the pod is running. And you actually should do that. Like, usually it doesn't make much sense to start a pod with an ephemeral container already coded in. It doesn't really make sense. To really drive home that ephemeral containers are not like normal containers, there are some technical implementation details around it. If you have worked or if you have developed a controller on operator before, or if you have tried to edit a resource with kubectl edit, you might have run into the concept of sub-resources. So, for example, the status field on a deployment, for example, or but honestly, most resources have a status field. That's actually a sub-resource. And that means you cannot talk to it directly. If you talk to the Kubernetes API and you like do calls against the pod API, the ephemeral containers changes will be dropped from it, because you need to call the specific sub-resource of it. Otherwise, Kubernetes will ignore your changes. So if you're working on this, just be aware that, for example, in controller runtime, this is how the call would look like to update the ephemeral containers. It's not a simple call to like pods update. It's a call to a specific sub-resource. And in this case, controller runtime actually has a method for it. But if you like add arbitrary sub-resources, it doesn't. So yeah, just be aware of this, because it's fairly important when you do like a kubectl edit and you can't figure out why the ephemeral container is not being added. Instead, we use kubectl debug. It is a command in kubectl, and it allows you to launch ephemeral containers. You can do this without it, like you don't really need it. The API is, if you do the sub-resource call, it's available to everyone. But kubectl debug just wraps it in a really nice command line that gets you started very easily. Here's a quick example. kubectl debug works the following way. You target a specific pod. You don't interact with a deployment because you want to interact with one specific pod. So you give it a pod name. In this specific case, I also want to have an interactive shell into the ephemeral container that I'm starting. So I'm passing the I and T flags. I want to, or I have to, pass a specific image that is used for the ephemeral container. And this is also an optional flag, the target flag. And the target flag is pretty important if you want to debug, because it means that you are now sharing a couple of namespaces, most importantly, the PID namespace. And we're not talking Kubernetes namespaces here, we're talking like Linux kernel namespaces. But essentially, to debug, I need to have access to the process that I want to debug. And with the -- target, I target a specific container that is already in the pods, and I make sure that my ephemeral container is sharing a couple of namespaces with that. So I'm breaking up container isolation a bit deliberately, so I can do this. If I run this command, I will be dropped into a busybox shell, nothing fancy here. But the important bit is, if I look at the processes that this ephemeral container has access to, we are seeing my shell that I just launched, and we're seeing the ps command to look at all the processes I can see, and there's the /bin/app. And that's weird, because that's not in my ephemeral container. That's because I broke container isolation, I shared namespaces, and that means I can see what is going on in the main container. And that means I can actually run my debugging against it, because I suddenly have access to the process. One last thing. I talked about capabilities earlier. I talked about passing, or about the required capability that I need to be able to trace a process, the capsys ptrace. And this is not by default in this spec for an ephemeral container. And it shouldn't be, really, because it is a very, very dangerous capability. So what we did here, I can see the process, but I can't attach to it. And I shouldn't be able to, because this process might be, I don't know, it has my S3 secret key loaded in memory or something like that. And I really don't want people to be able to just extract that. So what I need to do is I need to find the right -- profile, because kubectl debug has an additional feature. That additional feature gives me some kind of pre-configured specs for my ephemeral container. And there is one profile that gives the capsys ptrace. So that is kind of the easy way out, because that is the profile I want to pass, because I want to be able to ptrace my process once I have broken down process isolation. Putting all of that together, this is now everything, all the basics coming together into my actual use case. I want to launch Delve as an ephemeral container, because that means I can start debugging my application right where it is, right in Kubernetes. And maybe you have like a good observability stack in place, so maybe you already have an idea where the problem is, but you just can't narrow it down well enough. So in this case, you might want to run a debugger just to like really go, or let your code go, or let your code run step by step. So at every step you can see, okay, what is happening with our variables? Where is it going wrong? And if we put it all together, we have this, well, kind of a behemoth of a command. But essentially, what we need is we need kubectl debug. That's the whole why we're here. We need the -- profile that I told you about. So there is this general profile that gives me exactly what I need, the capsys ptrace capability. And that means, yeah, I will be allowed to attach to running process. Then I'm targeting my specific container, because again, I need to break down some isolation. I need to be able to attach, first of all, I need to be able to see the other processes in the container. Then I'm passing a specific image. I build my own Delve image for this purpose. I think there are newer Delve versions out, so maybe build your own one, or hopefully I'll be able to update it. But essentially, I'll pass an image that has Delve on it. And this can also help a lot if you're running into problems with, for example, distroless. Distroless does not have any tools on board, so the whole kubectl debug is very, very helpful if your core app container is very constrained in what tools it has on board. Then I'm targeting my specific pod, the pod that I want to go into, and I pass the command that I want to run. So in this case, I know what command I want to run, so I'm not opening an interactive shell. I just pass the delve command. I open up a port on localhost. That is all we need. We're going to see later why. We're opening a headless mode because we want to act this, or we want this to act as a DAP server. And then there's a couple of things like I can accept multiple clients. This is the API version of the protocol that Delve has internally, which works similar to DAP. We don't really care about that. But then we attach. So we attach to the process with process ID 1. And if you remember the slide that I showed earlier, where I run kubectl debug the first time, since I'm attaching to a container, the container will always have a PID 1 that is the process that initialized the container. So if you just directly launch a Go application in your container image, then you will always know, okay, this is PID 1. So if you don't do that, then maybe you actually need an additional step of using an interactive shell or having a command in place that figures out your PID. But in a simple Go application, this should be really always PID 1, so you can kind of guess that. One last thing. I locally want to access this. I also don't want everyone to be able to access this debugging port because, again, being able to debug an application has a lot of implications on the data loaded in memory on that application. So I do not want the ephemeral container to open this port wide to everyone available. And I bound this to localhost, if you see here. So it's not like if you try to connect to the pod IP with this port, it won't be available. But if I do a kubectl port forward, it will be available. So I tunnel into the pods because the ephemeral container is running there. There is something listening on that port, and then I can connect to the localhost port that the kubectl port forwarding opened on my machine. And again, this is basically how you can then connect to the locally open socket that is tunneled all the way through to your Kubernetes cluster that might be running, I don't know, on a different continent. This is all nice, but I will be completely honest. Whenever I try to do this, I need to look at the Delve help. Like, I have no idea how to use it efficiently. I always forget all the commands. So I kind of want to integrate it with the IDE of my choice. And for most people, that is probably Visual Studio Code. But DAP is not a protocol that is exclusive to Visual Studio Code. So if you are someone who doesn't use Visual Studio Code, you still want to get into this, not all editors have something available. Not all editors have a plugin available. But for example, I am a big NeoVim fan, and NeoVim has a DAP plugin. So I can use this within my favorite editor of choice, and I don't really care. It's a protocol, it's a standardized one. As long as your IDE supports it, you're good to go. And just to take a quick look at a file format that if you're using Visual Studio Code, or if you're using the NeoVim DAP adapter, because it helps with that, this is the file format that you need to pass so VS Code understands how to attach and how to connect. And a few interesting things here are, I want to use the DLV DAP adapter. So I want to speak DAP with a Delve instance. And something also kind of important, since Go compiles the paths to your source files into the resulting binary, except if you trim the paths, but Point being is, I need to tell the debugger that instead of the paths on my local system, which might be under home, mbig, somewhere, I wanted to use the path, the path that I used when building the Go binary. And in my example, I built the Go binary in a container in /build. So that is where I wanted to attach, to substitute in the code, like the source file names, so my debugger knows where to set the breakpoints and what to send to Delph. And then I want to connect to localhost on the specific port, because that is where I actually connected things. Real quick, this is the application Docker file, still on Golang 1.19. Again, please don't copy. I did this for the talk and then didn't update it. But essentially, you can see here that I'm building within the /build workdir, and that this is why I substituted in the /build in my debug configuration. And putting everything together, I don't think we really have time for the live demo, but that's okay, because all I just showed you, all the commands, I can run them for you, but I hope you trust me enough that they are working. This is the final result. It doesn't maybe look like much because especially the demo application code that I wrote is really stupid. Everyone can figure out what's going on here. But the important bit is that I connected via kubectl port forwarding into an ephemeral container, running my Delph debugger on demand. And this is the code on my local system. So this is where I have all my developer tooling, and I can access things like the local variables here. And it just works. You have all your tooling available, and you can work from here, and you can use all the debugging capabilities of your IDE. Bonus picture, same thing in NeoVim, because, well, it works in more than one IDE, and you see a very similar pattern here. I can access my locals, I can interact with them, I see my code, I see what's going on here. And that's it. One last thing. The interesting bit is if you maybe, I don't know, if you go back and watch this talk in earlier versions that I gave of it, things changed a little bit. All I can tell you is, if you do this, do not forget to pass the /target flag. Because if you don't, you get weird error messages because you're trying to attach to your own process. And yeah, that gets really confusing. And it creates problems, and then you say wrong things in talks. Don't do that. And that's it. Thank you very much for listening. And yeah, okay. If you're interested in more material, there's a companion GitHub repository here that you can find through the QR codes. The slides will be updated there soon as well with this version of it. Okay, thank you.
Thank you so much. It's really interesting to hear more about debugging, because in the Go community, we talk about profiling a lot, but not so much about debugging. So one of the questions that we have is, how do you bake the debug version of your binary on the running application container?
Yeah, so I showed you the build flags. You can set those while building your normal application container, but you might, and you likely will, have a performance penalty from that, because the compiler suddenly doesn't optimize your less than optimal code pairs array. So you can't really bake it in and switch it on demand. You can't replace your process in place. But if you see something going on, you can try with the unmodified version, or you have a specific debug image available and you restart your application to go into that mode, and then you can go debugging without the compiler being in your way.
Cool. The next question is, would a breakpoint halt the production program until you move or release it?
Yeah. I mean, depends on if you're running in a specific Go routine, or only the Go routine that you're in would be stopped. If you don't have Go routines going on, then yeah, the full program would be stopped until this is served. I believe. Again, not the biggest expert on Delph, but that's my understanding of it. So yeah, your HTTP request wouldn't actually go through until you continue the breakpoints, if it's like in the code that handles the request.
Cool. And the last question, does the profile flag also get around pod security context?
Good question. No, it does not. I think pod security contexts, yeah. So the capability is actually part of the pod security context in an ephemeral container spec. That means it doesn't, like the profile flag doesn't do anything magic, it just sets the right pod security context. That also means if you have policies in place forbidding that, because it's a company policy or it's just a general security guideline, this will not work. And that's good because someone did not want you to do this. But yeah, it's no special magic.
Awesome. That's all we have time for. Give one more round of applause for Marvin.
Thank you.
Really excellent talk.